Hello, relativity friends. Some time ago, I bought a book off of this website on general relativity, and I wrote a review on and put on YouTube. And the author, uh, he sent me email and said, "Hey, would you like to review another one of my books?" And I said, "Absolutely." So he sent me this one, "The Mathematics of General Relativity." I've had several days with it, and the reason I could do that in just a few days is because I'm very comfortable with, I'd say, three-fourths of this book I'm very comfortable with. I understand it. I've seen it before. I've done it. The rest of it was I'm not that familiar with, and I enjoyed that part. And I'm going to continue to study those parts. Now, let's talk about what this is. This is a book that is geared toward using tensor calculus and differential geometry applied to general relativity, as compared to, of course, like this, which I'm always harping about how good this is. This is a channel on YouTube on tensor calculus, and it's by far the best one on YouTube. This is a course uh, from a professor of mathematics, and it's geared toward mathematicians. Now, that's not to say there isn't some applications in there. There's a little bit. You certainly, if you completed this entire course, could apply it to general relativity, but that's not its goal. Its goal is to teach you tensor the calculus, as opposed to this course, which is geared toward general relativity. That's the whole point. Okay. Now, this this course is not complete. All right. It goes up through Christoffel, the symbols. The next one, the covariant derivative, is coming soon. And the one I'm waiting on, really, differential geometry, is not released yet. Now, my understanding is if you buy this book, that when these are available, you can come back and get them. So you just download each one of these as a PDF and their chapters. And what we're going to do is go through and just very briefly look at each chapter. I just got a few things to say about each one. All right, so let's get stuck in. Okay, the first chapter is the tensor index notation. Now, if you are unfamiliar with working with tensors, you really need this chapter. It's boring, but it's very necessary, because if you're not comfortable with the syntax used in tensors, you're going to get lost. Also, he assumes now that up to this point that you've had vector calculus. All right. So some people call it calculus 4, but you've had a vector calculus. You're comfortable with partial differential equations. You have some knowledge of linear algebra. So those are the assumptions to jump into this. Okay. So you need this if you're not comfortable with doing it. That's all I can say about it. Okay, lesson 2. Now, this is about coordinate transforms, okay? Lesson 2, I don't know why I keep going too far down, but I do. I'm sorry. The coordinate transforms and the Jacobian, the matrix. Now, in a lot of books I've had, they will uh, start the coordinate transforms and do it algebraically, but he does not pull any punches. He goes straight for the Jacobian. I really, really like that. Uh, because with students, you're trying to teach students, you don't want to give them options. You really don't. You want to say, here's the way you do coordinate transforms, use the Jacobian. And that's and that's the right way it should be done. And if you stick to it very consistent, I really like this section. I think it's good for students. By the way, I forgot to talk about something. Who's this book for? This book is for students or continuing education to people like myself, or as a reference book. This book would be useful to anyone. If you're a student taking tensor calculus, this book would be an asset to you, because it may have different things in it than your text, and that's certainly true for me. I have 2 tensor books, and there are things in here that are not in my text. So it can be useful to anyone. Okay, that was coordinate transforms. Let's do vectors and covectors. Now, when I started this journey about this winter will be a year ago. I had some old books, and they had contravariant and covariant, and then on YouTube they have vectors and covectors and basis vectors and dual basis vectors. It's so confusing to students. He uses the modern notation, the modern words, the syntax. There are vectors and covectors, and that's what you should be talking about. It makes it a lot less confusing. This lesson, number 3, is not essential for your path into general relativity. There's a lot of the math, the formulas in here, but I think it's a really fun the chapter. I like it. It's interesting. It isn't necessary, but it's interesting. So it's up to you. If you're a student and taking tensor calculus, it's absolutely essential that you do this. If you're like myself, a continuing education, the person, it isn't necessary. So it's completely up to you. All right, let's keep rocking. The metric tensor, my favorite. Okay, on your journey in general relativity, this is absolutely mandatory that you understand this. It is the key to general relativity. There's nothing else to say about it. It's so important. You truly need to understand it, what it's for, what it does, and how to do it. Okay? Now, in most of his chapters, he has applications. I absolutely love that. These applications, like I said before, are the mathematics geared toward general relativity. All right. So here's some examples. Now, so you've just spent all this time studying this, and now you're ready for some applications to this. And this is the most famous one, the Schwarzschild, the metric. So he's got you geared up. He's going down, bada bing, bada boom. Oh, he springs it on you. Here it is, the Schwarzschild metric. There's absolutely no evidence anywhere where this came from. I don't like that. I really think by the time you get to this part of the book, he should have taken the time to derive this. It is a long and tedious derivation. It's a lot of fun too, by the way. And it really helps a student to learn where these components come from. So I don't like that. You should have shown the derivation. That's all I got to say. Okay, where are we at? 4. Let's go to 5. Introduction to tensors. Let me see what my notes are saying here. Okay, this is an introduction basically to tensor algebra and how you work with different components. This is essential. This is essential for you to continue because you've got to become very comfortable with how to convert the tensors, how to reduce the tensor, and also once again he has some examples at the end which are very, very good. So this chapter is essential in your studies. Chapter 6, working with tensors. This is basically more of the same, which is the way it should be. I really applaud the way he built this book. He built the chapter before goes to the next chapter, and that's based on the chapter before. I really like that. That's the way it should be. So you're going to learn in here some more the tensor algebra, and you're also going to learn some of the things you will do in solving the Einstein field equations. So this is important, and it's got a lot of heavy math in it. So I really like this section. And this is one of the sections I'm going to go back and study over and over because I'm not 100% comfortable with this section. So I really like it. All right, let's see what's next. Okay, here is once again, a totally unnecessary but very interesting chapter. It's called, what did he call it? He called it Tensor Densities and the Metric Determinant. Okay, I know absolutely nothing about this, and I've read through it briefly. I'm going to go back and study it. This is another of the chapters. So the one before this and this chapter are the ones I'm going to be spending my time on. I think they're very interesting. I don't think they're very practical for your trip into general relativity, but they are a lot of fun. And you know that fun's what it's all about. Okay, here's the last chapter that is available as of now, the Christoffel, the symbols. And this is absolutely positively important. The metric tensor and Christoffel the symbols, you must understand those to work in general relativity. They are crucial. So you really need to pay attention to the metric tensor chapter and the chapter, or else you're not going to get anywhere. It's very, very important. So overall, I like this book. I think it's well thought out. I think he did a lot of work on this. I like the format of it. I like the professionalism of it. And is it worth the money? Yes, it is worth the money. If you can afford it and you're a student or you're a researcher or you're like myself, a retired person who likes to learn new things, this is a good book. So I highly recommend it. All right, I'll see you later.